in a probabilistic way. We usually work with some kind of risk assessment. And in this case, when we were talking about risk of blocking the evacuation route, we used event tree and calculated the level, the risk level, and then compared the risk level with each other. And in the model, we looked at the probability that a door is blocked open, the probability that the self-closing doors failing to close correctly, and the probability that the fire resistance structure wouldn't achieve the designed fire standard. And the consequence of this event was how many occupants will not be able to evacuate. So the risk measures was like a qualitative measure, like, okay, we've got 9 apartments, then it's 9 people that can be will have a problem to evacuate. If we have a problem to if we block the evacuation route, but if my reference building we only have 8 apartments, then it's only 8 persons that could be blocked, that could be exposed to terrible condition, and that will be my consequence in my reference building. By doing this for both kind of buildings, my design and my reference building, I could compare the safety and the risk level and calculate some kind of safety margin. How safe is this building concerning the deviations that I shouldn't block the evacuation routes. And yeah, we use some kind of event tree, you use some statistical distributions to do it, and the result is in a histogram like this. And when you have done this, you know, yeah, it worked out, but how uncertainty is the model, how much sensitivity does it have, and how robust is this 5-state concept that I work with. And to show this, I did some kind of regression analysis to see what parameters will affect the result most. And I could get a diagram of that. And when I know which parameter that affected the result most, then I could work with that parameter in detail, change it, and see if the result still the same or what will happen. And for this analysis, I did some equilibrium calculations as well. You know, I tried to calculate the state limit function. When will the reference building be better than my actual design, to see how much safety level do I really have. And of course, I did some robustness analysis as well by highlight different aspects of the facility strategy that could be a problem if I have a more functional electricity in the building. And talked about the robustness part of it. And for the actual design, was it okay or not? Yes, it was okay. It was. I could use this kind of design where I have 15 meters in my dead end and still have the level of safety that the society defines. So I could say, yes, it's okay, let's go. But if it wasn't, then I had to go back and do the process all over again and put in some more measures in my actual design. Then I maybe had to work with sprinklers or fire alarm or something like that to see when could I reach the same level of safety. But if we go back, will it work then in practice? Will it be a good technical specification for the consultants, for the building authorities, or for the local authorities? I think so, but there are some challenges that we have to work with. And the biggest one, I think, is about how should I define my reference building. Is it okay that I have a 3-story building compared to a story with 15 floors? Well, in Sweden we have the same building codes for these kind of buildings. Or when I work with the occupancy, yeah, I have a residential building, this big complex, or a small cottage. It's difficult to define your reference building and know how I should do it and how extreme can I do it. And I think we have to work more with this part of the technical specification to ensure that my equivalent reference building is good enough. But we also have a problem when we working with this method, that we don't have scientific support for the pre-accepted solutions. I don't really know why we talk about 10 meters when I should talk about the level of risk of being blocked in my evacuation route. It's difficult to understand what does it really mean. What is the meaning of this pre-accepted solution, and what is the meaning with the regulations? In Sweden we have a lot of deemed satisfied solutions, and we don't have a whole picture why it is. And these are challenges when we do this kind of analysis. But we also have challenges in what kind of analysis we can use. We are talking a lot of this fire safety engineering methods, and it's you can use it on every kind of fire safety objectives, but we don't have any good tools to do it. We have good tools when it comes to the asset analysis, but we don't have so many useful tools or methods when we talk about objectives, about the lining on the wall and things like that, or the rescue services. We don't have these tools to work with it in a good way. It's a big chance to go there. But hopefully it will be a new project about this. The future will come really soon. In about 1.5 weeks, our new project will start, and it's also a Nordic collaboration between all Nordic countries. And it could be like the next step in this fire safety methods and to define technical specifications and hopefully even technical standards on how to do things. The new project that will start is called Fire Safety for Innovative and Sustainable Building Solutions. It's a bit difficult name to say. But the aim of the project is to create new verification methods from a practical perspective. Often we talk about this is about processes, the flow to do things, but not so much on hands-on how to do it when you are designing. And hopefully it will be 2 new INSTA standards. And one is for the method, and one is on the guidance on the process of safe and innovative fire safety design. And I think Iceland is a part of this year. Björn and Bödva Thompson can be a part of it. And I think Iceland is work package leader for one of the package in the project. And it will work with the identification and analysis of the barriers to innovation and trade. It's an Icelandic part of this project. But it's 5 more work package to ensure that we manage to do 2 new standardizations. Well, that's for me. Do you have any questions?
Good.
Yeah.
Thank you very much, Johan. I was wondering about the exam you took.
Yeah.
You have a bit different, or maybe stiffer regulation here in Iceland, obviously. But I was wondering if it would be necessary in that case to take a more whole building perspective, as we have, for example, an open staircase situation where if you increase the number of apartments every floor, you increase the total number of apartments.
Exactly.
And thus the total number of people affected will be increased as well.
Yeah. In Sweden, when you do performance-based design working with fire safety methods, it's always about the whole building. But when you do this comparative analysis, comparative approach, and you use your reference building, it's possible to take out all the different parts that isn't the same. I only work with one floor because it's the same. If I find a solution for this, and I could ensure that the level of risk of blocking the evacuation route is less in my actual design compared to my reference building, then the whole building will have the whole building's level of safety will be better than the reference building. So you break it down to sub parts of a building. Yes.
What would you say was the biggest news in this instant 950 standard? Because it seems to be a collection of various things seen before in S&P and Swedish regulations and guidelines and stuff like that.
Yeah.
Lot of Swedish stuff.
A lot of Swedish stuff, yeah. And I think it's because it was initiated in Sweden. We got this. In Sweden, we have some kind of pre-accepted solutions even for the fire safety methods to use. And I think that was one of the foundings for the But the new part of it is mostly the process of describing how you could do it. That it's written down. It's nothing new. It's the way the consultants have done earlier, but we haven't put it down like this earlier. And it's a good way to start a Nordic collaboration again.
So we have what we have out of it is that we have the same platform.
Exactly, the same platform. Yeah.
Between what you count.
Yeah.
So that's probably the biggest news in it.
Exactly, it is. Yeah. So we could work over the borders. Yeah.
I was wondering about what was the biggest obstacle in working with different Nordic countries regarding this?
The biggest obstacle was that fire safety engineering and the concept of that is not the same in all the Nordic countries. It's a bit different when you talk with the Danes compared to talk in Sweden or you talk with the Norways. Like Sweden and Norway are two of the most liberal countries in the world when you work with fire safety engineering. And in Sweden we don't have any good auditing systems. So it's we have the freedom to do as we want to do, as long as we could show that the level of safety is correct. But I don't have any authority to check that I'm doing it in the right way.
So you still work with third-party control?
Yeah, we do.
Internal control?
Exactly, but it's within the consultant industry that we have this kind of specialist that they can talk with to do the third-party control. Yes?
Yes, I have one question concerning your example corridor. I'm surprised that the staircase is not closed.
In that country, yeah. Like in Sweden, it's okay to have an open staircase.
Okay, because then you have the same smoke compartment between floors, so people could be
if
stuck.
I got 5 stories and I got a fire on the first floor, then I could have a big consequence on the whole. Yeah.
But in this case, I mean, putting a fire door could be a way to lengthen.
Exactly, yeah. We could work with that.
It's costly
as well as your initial design. If you put this one as a fire safety design, this could be okay to only have one fire door on level 1, and then the level of risk should be okay.
And I hope that in Hong Kong you don't consider windows as fire escapes.
No,
because
really in Sweden, yeah. So you have to know what kind of regulation you have in your country and what are you allowed to do. So this example is quite special in Sweden. What I've heard, it's okay to do it in Sweden, but not in other countries. Only if you do it in Australia, for example, then you have to put in sprinkler and fire alarms as well to manage to get the same thing. But it's all about how you have defined the regulation and what kind of pre-accepted solution you have to fulfill this regulation. Any more questions? Yeah.
I think it's possible this install will be sometimes
Yeah, hopefully it would be. It's one of the aims to get the European standard as well. But I think it's easier to work on a Nordic level because even if there are differences between the building regulations and the way to work with fire safety methods, the concept is the same, and we build in quite similar ways. But if you compare the Swedish way of building with the Greeks way of building, is a bit different how they see it and the process. Yes.
One comment for this, because I think half of the designers here in Iceland have been in Lund.
Okay, yeah.
So I mean, I think most of the fire safety guys in the Nordic countries have the same education. It could be a very good insight, to have a Greek insight, or maybe something more Southern European.
Exactly.
Because Nordic countries are kind of a small community.
No, yeah.
And all the same kind of thinking.
I think it could be good to get that information as well, to mix up our Nordic way of seeing things.
I have one detailed question.
Yeah.
From the standard.
Yeah.
I'm just curious because you have a design fire in Springfield that goes up to the classical 5 megawatts.
Exactly, classical 5 megawatts.
And then it goes down again.
Yeah.
Do you know where it comes from? What project?
Yeah. The design fire concept when we work with the ASAP analysis in the standard, it's part of the Swedish regulation that is in the standard. And this kind of working with it's when you have a sprinkled building. In Sweden, we are allowed to work with design fire that increases alpha T2 square with fast as the alpha until you reach the point where the sprinkler will activate. And then my design fire will be constant for 1 minute, and then after that, under 1 minute, it will decrease to 1/3 of the maximum value. And it's nothing about a real fire, but it's some kind of design values that was some kind of a copy from the NFPA standards, I think, and taken into the Swedish parts and tried to get a twist on it to be a way that would be okay to work with when you do analysis in Sweden.
I was just curious.
Yeah.
Where it comes from?
What I heard is in the technical specification it comes from Sweden, and in Sweden it comes